Okay, so now let's continue to the last part. Here we'll first do some technical jobs to solve the problem, and then we will analyze, we will discuss what we find in this problem. Okay, so we will introduce to you the standard way of solving the standard two-type problems. This method has been found for around 30 to 40 years, and eventually it has a great impact in a lot of different fields. Okay, so it's worthwhile for you to understand how this works. The key is that we want to analytically solve this problem. Only with analytical solutions we may generate some insights we need, okay, and we will discuss this at the end. So our first step, or our first thing to analyze, is called monotonicity. The thing is that by observation, if we add the two IC constraints, okay, this is ICH, this is ICL, if we add them together, what will we get? We will get this. This is these two parts. This is the other two parts. TH, TL, TL, they will cancel each other. And then you may do some arrangements, and eventually you can see that your conclusion is QH is greater than or equal to QL. So what does that mean? Every feasible solution satisfies this inequality. So that means in any incentive compatible menu, the high type consumer is going to consume more, is going to be offered a higher quantity. Okay? Intuition, why this is true? Because high type consumers prefers a high consumption, right? Because if you go back to check their utility function, because theta H is high, and that's why for each unit of consumption, the consumer gets more. Okay, so high type consumers prefers a high consumption, and that's why QH must be greater than or equal to QL. Okay, now step 2 is to see that IRH, this particular constraint, is redundant. In particular, actually we can say ICH and IRL. These two constraints imply that IRH is redundant. According to ICH, this is greater than or equal to the other thing if the type H consumer chooses QLTL. And this is going to be greater than theta L, because theta H is greater than theta L, right? And finally, this is nothing but the left-hand side of IRL, and that's why this is going to be greater than or equal to 0. So this tells us that the high type consumer earns a positive rent, right? This is his right-hand side. This is always going to be greater than 0. So the high type consumer always earns a positive rent. Full surplus now extraction now becomes impossible. Okay, with this in mind, we can remove one constraint. The problem reduces to this with only 3 constraints. Now we can do something more. Let's do ignoring ICL. Okay, so we're going to guess that ICL will be a redundant constraint. If that's true, then why not ignore it for a while? Okay, the reason that we make this guess is because let's go back to intuition. If my valuation is low, do I want to pretend to have a high valuation? I guess the answer should be no, right? If my valuation is low, I want to say it's low. It is the high type consumer that wants to pretend to be a low type consumer. If the low type consumer has no incentive to pretend, to lie, then ICL is useless. Anyway, technically, now we're going to ignore one constraint and solve the relaxed program. If the optimal solution satisfies the relaxed constraint, then it is indeed optimal. So we relax one constraint, now we have only 2 constraints remain. Okay, Now we can immediately observe that the remaining constraints will both be binding at the optimal solution. Okay, so we now have ICH and IRL. ICH must be binding. Why? I want TH to be as high as possible, and TH only appears here. I want to set TH to be as high as possible, but that's going to decrease my left hand side. So I can do that until the first constraint is binding. Okay, so ICH must be binding. Similarly, IRL must also be binding. So I want TL to be high, 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 and high. And that's going to do two things to my constraints. The important observation here is that when I increase TL, constraint ICH is going to be relaxed rather than become tighter. Okay? Because increasing TL decreases the right hand side. So it is not going to violate ICH. The only reason that I cannot increase TL is because IRL is binding. Okay? So IRL must be binding. Here, technically, we should mention that if you did not ignore ICL, as we did in the previous slides, okay, ICL is this one, then we cannot claim IRL is binding, because in this case, if you increase TL, then it will also make ICL more likely to be violated, and when that happens, you do not know whether ICL or IRL will be binding before the other one is binding. Okay? Anyway, you really need to ignore ICL to complete this stage. Okay, so now things are very good. The problem further reduces to this. Okay, we have two equality constraints for our four variables. Now we can remove these two constraints and replace TL and TH by what they should be. TL is nothing but theta L times VQL. And knowing that TH is nothing but this term, you take TH to the right hand side, take them to the left hand side, replace TL again, you get TH to be something like this. Okay, you can replace TL and QL in the objective function by these two terms, and then get an unconstrained problem like this. Okay, here unconstrained is actually not the fact, because QHQL, they somehow should be non-negative, right? This is some kind of implicit constraints. So anyway, unconstrained here just means the original four constraints disappear. All you need to worry about is non-negativity, and the problem would be like this. Okay, so through some arrangements, you can see that we are maximizing this particular function. The first part has nothing interesting, but the second part, you have these two terms minus an additional term. This term does not appear in the low type part. Anyway, because the v function is strictly concave, this whole function is strictly concave in QH and QL, and of course first order condition. Okay, and eventually after some derivations, you may want to verify the following thing is true. Suppose this condition is true: theta h minus theta l over theta l is less than beta. In this case, the second best solution, okay, which is a menu of two contracts, must satisfy these first order conditions. For QH, when you do differentiation, QH appear only here. So that's why the QH first order condition is very similar, or actually identical, to the one you saw in the complete information case. But for QL, is here, is here, is here. Okay, so when you differentiate with respect to QL, you get several terms, and eventually after some derivations you can see this. One thing to mention is that if this condition is violated, you can show that the denominator, this part of the denominator, will become greater than 1. Okay? And then the whole right hand side would become negative. But as you expect, this is impossible because v is increasing, so v prime is always positive. Okay? So it's impossible for the first order condition to hold, and eventually that means your QL must be 0. And again, and that does not affect your QH. Okay? Anyway, let's focus on this assumption, which is the general case. Typically, this is true. And then we're going to proceed by assuming that the second best solution is something like this. Okay? Again, because you do not know exactly what V is, so all you can do is to have a characterization of QH star and QL star. You cannot have a explicit or closed form solution for these quantities. So the last step is to verify that ICL is indeed satisfied. To do this, we apply the two equations we got when we find them binding. Okay, because these are something must be satisfied by the optimal solution. So an optimal solution satisfies this, and now we can show that this our ICL constraint will become this. Okay, actually this is a typo, so let me correct it. It will be Q theta H minus Q theta L times negative V of QH minus V of QL. Okay, try to verify this at home. But anyway, yeah, you can show that the right hand side should be negative and the ICL is indeed satisfied. Okay, so technically that tells us, yeah, definitely the solution we found in the previous slides is optimal. Okay, also this verifies our conjecture or intuition that ICL will always be satisfied by any optimal solution. So that means, yeah, as long as our contract makes sense, then the low valuation consumer will not claim he has a high valuation. Okay, so now it's time to do some discussions and interpretations. So first, let's consider the consumption levels. Here I want to show you inefficiency comes again. So in the first best situation, consumption levels Q tilde L and Q tilde H satisfies these two simple first order conditions. Okay, I can find unique solutions for Q tilde H and Q tilde L according to these two conditions. And now the second best consumption level satisfies the following things. Okay, for QH is basically the same, but for QL we know the right hand side is something like this, and you may verify that because theta H is greater than theta L, the whole thing here is positive, and that means this part, the denominator, is less than 1, and that means the right hand side here is greater than C. Okay, so what does that mean? First, the high type consumer consumes the first best amount. The consumption level here are identical, but what's different is for the low type consumer. For the low type consumer, as we may verify, okay, V prime of Q tilde L will be C over theta L, right? You take theta L to the right hand side. And this is going to be less than V prime of Q star L. Why? Because this term is the right hand side divided by theta L, and the right hand side is greater than C, so this first order derivative is greater than this ratio. Okay, So if V prime of QL star is greater than V prime of QL tilde, as V is strictly concave, we know low type consumer's quantity will become lower than the efficient level. Okay? And we know this means inefficiency. We cannot make the social welfare to be as large as in the complete information case. So this is how information asymmetry causes inefficiency, and the consumption level will only decrease, right? Inefficiency somehow means deviating from efficiency, but it may be fewer or it may be larger. Why do we know here the consumption level will only be lower than the efficiency level? Okay, think about this question for maybe 30 seconds and then see the answer in the next slide. So we mentioned that the consumption level must go down when we move from complete information to information asymmetry. Why do why do the seller wants to decrease QL? The reason is that under the first best menu, the high type consumer pretends to have a low valuation. Okay, he will choose the contract intended for a low type consumer. So to prevent him from doing so, we must cut down QL to make him unwilling to lie. We need to make the contract intended for a low type consumer to be sufficiently unattractive to the high type consumer. And to do so, the effective way is to make QL small, because the high type of high valuation consumer prefers high consumption. Okay, so this justifies why will we cut down QL instead of make it larger, because if we make QL even larger than the original situation, then it's even harder to prevent or to discourage the high type consumer to tell the lie. Okay, but anyway, yeah, this is something we must do, but it will create inefficiency inevitably. So regarding consumer surplus, okay, in equilibrium, the low type consumer will earn nothing. Okay, if you plug in everything back, you can show that low type consumer will still get nothing. But the high type consumer can earn a positive rent, as we mentioned. Okay, and exactly we can see that the high type consumer has a positive information rent. And that means because eventually when the consumer comes in, you do not know its type, right? So with a positive probability, the consumer is going to earn a positive rent. Or we say a consumer can earn a positive rent in expectation. Or we can say in average, consumers get positive rents. Okay? This is how we say information asymmetry protects agents or protect these consumers. Note that the high type consumer's rent depends directly on QL star. Okay? And this is the only thing that decided by the manufacturer in this expression. So that's why as a manufacturer or as a seller, I need to decrease QL because I want to limit the rents paid to the consumer, to the high type consumer. So I need to make QL smaller. But when I make QL smaller, efficiency will decrease. The total pie will become smaller. So I'm making a trade-off between making the pie smaller and giving him just a little bit. Okay, so that's my trade-off, and eventually there is the optimal level. But anyway, the reason that we want to cutting down QL intuitively is to prevent this guy to lie, and eventually that's because we want to cut down his information rent. So now it's time to do a summary. We discussed a two-type monopoly pricing problem. we found the first best and second best mechanisms, and it's all because the revelation principle that we can find the second best mechanisms. We found that information asymmetry brings in inefficiency, in particular in the two-type monopoly pricing problem. Inefficiency is represented by the low quantity, low consumption level for the low-type consumer. For the first best and second best solution, we found something: monotonicity. The high-type consumption level is higher. The high-type consumer will consume more than the low-type consumer. Also, the so-called efficiency at the top. The high-type consumption level is efficient. It's the same as the complete information case. And no rent at the bottom. The low-type consumer earns no rent. Okay? So we're going to see 2 weeks from now that all these properties of the second best solution will continue to hold in a more generous model. Finally, as we always mention, information asymmetry is the thing that protects the agent and hurts the principal and social welfare. Okay? So as a principal, you want to find some way to deal with information asymmetry, and essentially that's the screening technique we just saw by solving the two-type problems. Okay? So we'll stop here. Next week, we will give you a paper discussing something related to our supply chain, and it will apply the two-type model, two-type technique we used in this week. Also, 2 weeks from now, we will generalize the model to have more than two types. Okay, that's all. Thank you.